So welcome students. Today is a very important topic, and today again this is the second lecture on this deep neural network. Today again we will try to explain the code with mathematics. Okay, mathematics and Python code both parallel. So we will try to solve one question, very simple basic question. Why we are solving the basic question? Because we observe many students what they are doing. They are writing the code. After then, without knowing anything, they are using ChatGPT or Gemini and they are running the code. If you are learning mathematics, then it is very easy to write the code. You can write your own algorithm, own model. Okay, so now we will try to explain the code after some time, step by step. So before I will explain something, back propagation. In the back propagation, this is our agenda today. Okay, we will try to explain how the back propagation is working. Already we discussed last time how the forward pass is working. Okay, last time we already discussed how the forward pass is working. Forward means mathematical notation. What I am doing, summation of xi. If you know our previous lecture, xi wi plus b. Okay, so this is the mathematical notation. Okay, last time we explained this is a forward pass. So we have done the forward pass. Now we are writing this by the help of z in our program. Z is equal to this, and we also use ReLU also. Okay, so this is my z. Z means ReLU. Okay, what is this actually? There are two inputs, and suppose there are two inputs x0 and x1, and so actually there is only one output, suppose, and there are two weight w0 and weight w1. So what is the meaning of this? I will sum. Okay, I will sum. What I will sum? I will sum my x0 and w0. So what we are doing? x0 w0 we multiply. Okay, then plus, I use plus x1 and into w1. Okay, so what we did, we sum. There are only two, suppose there are many, so I am writing because of this xiwi. Okay, then I am using one bias because there is only one bias is there. So I got one output. I am using ReLU. Okay, so ReLU means, what is the meaning of ReLU? ReLU means you have a function f of x, that is output is x and 0. It's depend on the condition. If x is greater than 0, then you will write x, otherwise 0. This is the meaning of ReLU. And if you will see my ReLU graph is equal to like this. Okay, from 0 to less than, if x is less than, then 0, otherwise x is greater than, then my value is this. Okay, so I am getting here x. So this is a ReLU function. So summation of this plus bias, summation of this plus bias, then after then I am using ReLU, is my z. Okay, so this is the Python code, and we have written in math. This is the mathematical notation. Okay, this is the mathematical notation, and this is the coding notations. So now I will come again. So this is my agenda. So before learning the back propagation, at first we will learn what is the chain rule. Now you can see, suppose we have a function z is equal to f of x and y. What is the meaning of this? We have a function, there are two variables, and if you want to differentiate this with respect to t, okay, with respect to t, now you can see in z there is no t. What is the meaning of this? There are two variables, the x and y, there is a t. Okay, x means this is also functions, and y is also function, and the variable is t. So what I will do, if I want to differentiate this z with respect to t, at first I will differentiate the f with respect to x, because in f there is a x. So f I can differentiate with respect to x. Same thing, then x I will differentiate with respect to t. Why? Because in x there is a t. Okay, same thing also, this f, there is another variable, its name is y. So this f I will differentiate with respect to y. Now this y I will differentiate with respect to t, because in y there is a t. So that is the meaning of chain rule. Okay, now see here, I will show you something. Now see here, in this question I have written one h of x is equal to 3 bracket open and total number of 5 2x square whole power 5. Okay, so if you are in high school, what you will do, you will multiply it. So 3 into 2 to the power 5, because of power is 5, 2 to the power 5, and x is square 5. So 5 to the 10, this is 5. Okay, done. Now you will differentiate. You already know what you know, dxn dx, okay, is equal to nx n minus 1. Means if you want to differentiate this xn with respect to x, the value is equal to this. Same we are applying here. If you want to differentiate this x, okay, with respect to x, so with respect to x, then this is nxn minus 1. Okay, so overall answer is equal to this one. Overall answer is equal to 3 2 to the power 6, 5 plus 1 6, because 5 to the 10. Okay, so 5 into, this is the final answer. Now I can also write this h of x, this same question. What we can write? I can write also h of x 3 into gx, where gx is equal to 2x square. Done. Okay, so what I will do, if you want to differentiate any function, suppose I want to differentiate gx, okay, and dx. So what is the meaning of this? I can write g dash x. This is the meaning of this. Means I am differentiating this g. Okay, that is the meaning of this. This is another notation. And second, and suppose, listen also. Suppose there is a you have a function, okay, d. Okay, suppose you have function d and g of x upon dx. What you will do? At first you will differentiate this g with respect to x. Okay, you will differentiate. Now if there is a value, then again you will differentiate this x. Okay, again you will differentiate this x with respect to x. I will show you here what I want to say. Now see here, at first I have written this 3 I have written here. Okay, 3 I have written here, 3 I have written here. Now this 5x 5 minus 1. So I am treating this is x. Okay, I am differentiating this is x, nx n minus 1. Because if you differentiate any function, you can see here d x की power n is equal to nx n minus 1, nx n minus 1. Now in place of x I have written function. So what? nx this is my x, n minus 1. Done. Now this again, this, what is this actually? You will also differentiate this also. This I want to say. So what I am writing, g of x. Okay, means I want to differentiate this g also. So this is actually g dash. This is g dash x. Okay, so now 3 into 5 x gx की power 4. 5 minus 1 is equal to 4. I will differentiate. I will put the value of gx 2x square. Then I will nx n minus 1. And this also I will put the value gx is equal to 2x square. And overall I will get at last this one. Now you can see both are same. This and this both are same. So what is the meaning of this? The overall is, if you want to differentiate any function and inside the function there is a g, okay, and inside g there is a h, and inside h there is a m. Okay, so what is the meaning of this? If you want to differentiate f, you will differentiate f. Okay, then you will differentiate g. Okay, then you will differentiate h, then you will differentiate m. Okay, so that is the meaning of chain rule. So one by one you are differentiating all the function. So meaning of f dash is equal to df upon dx. Getting? So df upon dx. Now in f there is a g. In f there is a g. So I will write here g. df upon dg. Then dg upon dh. Now dh upon dm. Now dm upon dx. Okay, now if you will cancel, you can see same. So this cancel, this cancel, this cancel. I got df upon dx. This is my task. I done. So because inside g g there is a h. So g I can differentiate only with respect to h, and h only I can differentiate with respect to m, and m I can differentiate only with respect to x. This is the meaning of chain rule. Okay, I think that you understand. So now again I am here also I tried to explain same thing also. Now I will come to my main motto actually. Okay, what is my main motto? Now see here what is the meaning of back propagation, what I am doing. So now I will show one best example. I will show one best example here. Okay. Now see here. So I have x1 and x2. Okay. So this is my x0 and this is my x1. Now x0 and x1. What I am doing? I will sum both value. What is the meaning of this? x0 w0 plus then x1 w1. Okay, I will sum. I have sum. Then I am using ReLU. Okay, then after ReLU I got the output. Okay, after ReLU I got output. My output is Z. Okay, this is the meaning of the structure. So once you got the structure, now what is the meaning of to come back? That is the meaning of backward pass. I will explain. So now see here what I am doing actually. I have written here R. So R means ReLU. Okay. Then after then I have written sum. Sum means because I sum all value. Sum. Then after then I have written mul. Mul means I multiply this and this. Okay, one by one I multiply. Mul, I multiply this and this. I multiply this and this. And bias also I am writing. Here I have not written bias. Bias also I will write. Then whole square. Why? Because I am finding the loss. Now listen here. What is the meaning of loss? Loss means loss is equal to predict. PREDICT. Predict minus target. TAR. What is my target? Okay. This whole square. Why whole square? Because maybe this is negative. Loss will be never negative. So I am writing in positive. Okay. So my predict is Z actually. My predict is Z. You can see. My Z is ReLU of x0 w0 plus x1 w1. Okay. This is my Z. Minus in my program I have written target is 0. So this is Z square and overall is Z square. In my program I have written this one. Okay. So my loss I am representing with L. Okay. Loss is equal to Z square. I have written. Now see here. So up to this you understand. Okay. This is the mathematical notation. So if I want to find the loss, derivative of loss with respect to W0. So what I am writing? D loss upon dW0. Okay, I am writing. Okay. So now see here. So loss with respect to ReLU. Now why? Loss with respect to ReLU. See here. My loss, this is my loss I got. My loss with respect to with respect to ReLU. Before ReLU is there. Okay. So loss with respect to ReLU. After then my ReLU with respect to sum. Now see here. My ReLU with respect to sum. There is a sum you can see. My ReLU with respect to sum. Okay. Now my ReLU with respect to sum. My sum with respect to mul. Now see here. My sum with there is a mul. Means I multiply x0 x0 w0 and x1 w1. So with respect to mul. Okay, now at last my mul with respect to my input, my mul inside the mul, suppose there is a x0 w0. Okay, my mul with respect to w0. Now if you have any confusion, what you can do, you can see also, I will subtract this, okay, done, this, okay, done, and mul done. Now you can see I have d loss upon dw0. This was my target, I got. So chain rule, we are using chain rule to update my weight. Okay, what is my task? My task is not to update only w0. My task is to update w0. Okay, dl upon dw0, dl upon dw1 weight 1, dl upon dw2 weight 2, dl upon bias. So how many weights are there? If there are infinite weight, you will update all. If there are infinite bias, you will update all. Okay, so this is my task, overall task. Now see here what is going on. Here again I explain the same program. So we have written my weight x0 and w1, x1 and x2. Okay, so there is only one input actually, one output only. So w0, w1 and w2. I will multiply all x0, w0 and x1 w1 and x2 w2. I sum, then I use ReLU, then after I got output, done. Okay, now see here what I did, x0 w0, x1 w1, x2 w2 plus bias. Then after I find ReLU. This is a forward pass. ReLU means max. Already I told ReLU means max out of this. So loss is equal to z minus my true value is 0. Means my target is 0. So this is z square. Okay. So now our task is to optimize the weight and bias. So my loss is very less. So there is a formula. The formula is equal to w0 for w0. Similarly for w1, w2, w3, wn. Okay. So w0 minus, this is the step size, into, and this loss with respect to w0, this loss with respect to w0. So similarly for w1 you will write w1 and this symbol step size into d loss upon dw1. Okay, so my final formula is equal to wi, okay, minus this step size into d loss upon dwi. Getting? And in place of this, our target also to find the bias also. What I will do? Bias minus step size into d loss upon d bias. This is my target. Okay. So one by one I will find, and then I will put the value here. That is my updated weight and updated bias. I think that you got. Okay. So this is my updated weight and updated bias. You can also write BU or WU something you can write. Mathematical. These are the mathematical notations. Now in this program, our task is this. This is my task. So in this question, what we have written one x0. My x0 input is 1, and x1 input is -2, and x2 input is 3, and my bias is 1. Now my x0, for the x0 my weight is w0 and weight is w1 and weight is w2. So my weight w0 is equal to -3, w1 is equal to -1, and w2 is equal to 2. If you will multiply this 1 and -3, if you will multiply this 1 and -3, if you multiply, you can see x0 w0 is equal to -3. Okay, this is -3. 1 into -3 is equal to -3. Same thing also -2 and -1. -2 and -1 is equal to 2. Okay, same thing also 3 into 2 is equal to 6. And this is my bias, done. Okay, now see here. After then what I did, I sum all. After then I sum all. Okay, after then I sum all. Now next what I did, I find a ReLU. ReLU means max. After then I find a ReLU. ReLU means max. So at last I got loss. What is the meaning of loss? Loss means z minus target whole square. Done. This is my output final. Now see here what is going on. So I will sum all value. x0 w0 plus x1 w1 plus x2 w2 and plus bias. So that is you can see also the first was -3 and then 2 and then 6 and bias is equal to 1. So overall answer is equal to 6. Okay, so what we have written, overall answer is equal to sum is equal to 6. Now we have used ReLU. ReLU means, what is the meaning of ReLU? Now listen here, what is the meaning of ReLU? From 0, from this to, if it is less than 0, then this is 0, otherwise it is max. Otherwise it is max. Otherwise it is max. So what is the meaning of this? ReLU means f of x is equal to x or 0, depend on the condition. If x is greater than 0, x, otherwise 0. So now here the value is constant, so it will be same value. Okay, 6. Now 6 is square, after then this is same value 6. So 6 is square is equal to 36. So loss is equal to 6 is square is equal to 36. This is my final answer. Okay, for the first iteration. What is the meaning of this? Is a forward pass. So by the help of forward pass, I got 36 is the answer. So now what is our task? This is a mathematical notation for loss. So ReLU sigma xi wi whole square. This is a mathematical notation. Okay, and how this is working? Loss is equal to ReLU, then after then sum, then you multiply x0 w0, then you multiply x1 w1, then you multiply x2 w2, then you connected bias, and after then whole square. Okay, so now if you want to update w0, if you want to update only w0, so what you are writing? Again I am writing del L upon del w0. I want to update w0. So what I will write? Del L upon del ReLU. Why? You can see, if I want to update before this loss is there. Okay, before loss ReLU is there. Actually what is this? Actually this is working like this. I will show you mathematical notation. Okay, so d and d y upon dx. What is the meaning of this? My y is this and x is this, dy upon dx. Again this is dy, this is dx, again dy dx, like this it is working. So I think that you understand. So this is my first, this is my loss, this is y and this is x. Okay, so if I want to update, I will go back, dy upon dx. Okay, done. So loss dl upon d ReLU I have written, dl upon d ReLU I have written, dl upon d ReLU. Done. Now ReLU upon sum. Why ReLU upon sum? You can see ReLU, before ReLU there is a sum, so again dy by dx. So how it is working? D this again y, this is y, okay, upon dx. So what is y? Y is here now, y is here and x is here. Okay, it is working like that, dy by dx. So d ReLU upon d sum, this is sum, d ReLU upon d sum. So d ReLU upon d sum, d ReLU upon d sum. Next, d sum upon d mul, d sum upon d mul. Now see here, this is my sum, and after then I multiply. After then I multiply d sum upon d mul. Here also multiply, here also multiply. Okay, so d sum upon d mul. So d sum upon d mul. At last d mul upon weight. You can see, if before multiply there is a weight now. After multiply there is a weight. Done. If you understand the point, so after then if you have any issue, you can also check also. If I will subtract this and this, I will subtract this and this, and I will subtract this and this. Now you can see w0 and dl, and this is my target. Done. Okay, I think that you understand. Okay, now I will erase this one. Okay, so now my loss is this. Now see here how it is working. This is a question. So loss with respect to ReLU, my loss is actually z square. So I am writing here, I am writing here x square. You can write any variable square. I am writing x square. So this y I will differentiate with respect to x. So what is the meaning of this? I will get 2x, because dxn upon dx is equal to nx n minus 1. Okay, so this is 2x. So what is x? X is ReLU actually. Okay, x is ReLU. So ReLU means x ReLU sum. ReLU sum. What is the ReLU sum? Okay, already you can see this is 6. Okay, sum is 6. So ReLU, because you are writing here ReLU. Okay, so ReLU sum. So this is 2 into 6 is equal to 12. I got 12. Now second, what is the meaning of this? D ReLU upon D sum. So D ReLU upon D sum means this is my ReLU. ReLU means, what is the meaning of ReLU? Whenever it is less than 0, whenever it is less than 0, then 0. If it is greater than 0, then 1. Okay, so here we will find in our program the derivative of ReLU. Okay, so if it is greater than 1, here always you will get 1. D ReLU upon D sum is equal to 1. Okay, because this is this value ReLU, this value ReLU is 6. Okay, this is greater than. Now next, now listen here. Suppose you have a function. Suppose you have a function f of xy is equal to x plus y, and if you want to differentiate, this f with respect to x, you will get constant, and y is constant, and dx upon dx is equal to 1. And if you want to differentiate with respect to y, this f, and then you will again get 1. So here x is means df upon dx is equal to 0, and df upon dy is equal to 1. So even you will differentiate with respect to x, or you will differentiate with respect to y, we are getting the constant means 1 every time. So every time we are getting 1. So this part I skip in my program. At last, this is very important. dmul upon dw0. This is very important. Now listen here. Suppose you have a function, okay, and there are two variables x0 and w0, and if you want to differentiate this with respect to w0, so what is the meaning of this? You will get x0 100%. Very simple. What is the meaning of this? Suppose you have a f is equal to x into y, and if I want to differentiate f upon dx, what is the meaning of this? I will differentiate f is equal to xy with respect to x, then 100% I will get y, because dx upon dx is equal to 1. Same thing also here. If we differentiate, so every time I am getting x0 means every time I am getting input. This is a logic here. Okay, every time I am getting input. So in my program I have written input. I will show you later. So this is only for w0. Similarly, you will work for w1 also. So this is w0. So at last I will put all the value. So this is first value, this is second, this is third, and this is fourth. What is this? I am putting the all value here. dl upon d ReLU upon d sum upon dmul, and dmul upon dw0. These values equal to 12, 1, 1 and 1. Okay, so these value I will update and I will write here. So this is my dl upon dw0. Now I will put the value here. Okay, this is my updated value. w0 is equal to minus. This is step size, and this value I got. The value is equal to 12. You can see already we find. So d loss upon dw0. Now I will put the value here, and I got this is my final updated with w0. Similarly, I will find the updated w0 and updated w1 also. Updated w1, updated w2, updated bias also similarly. And whatever I got, this value I will write here, where w1 minus step size into del loss upon del w1, w2 minus step size into del l upon del w2, and b minus step size into del d loss upon d bias. Done. So once I updated all value, now I will check my new loss. So new loss, how to solve the new loss? Again I will use the forward pass. So what is the meaning of this? At first I was here. Okay, I was here. Then I sum all value. Then after then I find ReLU. Then after then I find the loss. Okay, so I started. This is my first. I came here and I came here and I came here. Backward pass. What is the meaning of backward pass? I came here. Again I came here. Again I came here. Now again after then again I will use forward pass again next time. Okay, so next time when my weight are updated. Now see here, my ReLU sum means sum x0 w1. So x0 is equal to 1. You can check x0 is equal to 1, and updated w0 is equal to this, and x1 is equal to minus 2. Updated w1 is equal to this, and x2 is equal to 3 and updated w2 is equal to this, and this is my bias, updated bias. So if you will sum, this is z square, so my updated this new loss is equal to 33. Before the loss was 36. Before the loss was 36. You can see the loss was 36. Now after this backward pass, and again I found the forward pass. So after forward pass I got my loss is 33.87. If you will see also in program also same I got. I will show you. Up to this, if you understand, now I will show the program. Now in the program you can see what I have done. I have written my weight is equal to 36. Now weight is equal to 33. So this is only for one iteration. This is only for one iteration. Now I will show how the code is working. Now listen here. What we are doing, I am writing only 2. Suppose I am writing here 200 iterations. Okay, suppose I am writing 200 iterations. In this condition, how it will work? In this condition, how it will work? Okay, I will check. Sorry for that. Okay, so again I will run the code. Now listen here. After you can see my loss after 200 iterations, means 200 iteration means I go forward pass, backward pass, forward pass, backward 200 times. So after then I got my loss is equal to 0.000195 something. So my loss is very close to 0. Okay, so my updated weight are minus 3.39 and minus 0.20 and 0.80, and final bias is equal to 0.60. This is my final bias. Now what is this actually? How the code is working? I will show step by step. Now see here, I will go back. I will go back. Okay, now how the code is working. So at first I have written what I have written. At first I have written import numpy as np, done. After then I have written the same weights, minus 3.0, minus 1.0, 2.0. My bias is equal to 1. My inputs are 1.0, minus 2.0, 3.0. Same. Target is equal to 0. My target is 0. My learning rate means step size is 0.01. My ReLU. ReLU is the, what is the meaning of ReLU? From here to here 0, and after then from here to here max. Okay, this is the meaning of ReLU. Okay, so if you will see, ReLU means f of x is equal to x or 0. When x, if x is greater than 0, else, this is else. This is the meaning of ReLU. Okay, done. Now ReLU derivative. ReLU derivative. What is the meaning of ReLU derivative? So if greater than 0, now see here. If it is greater than 0, what is the meaning of it? dx upon dx is equal to 1. Otherwise 0. So I have written derivative of ReLU. If it is greater than 0, 1. Otherwise else 0. This is the derivative of ReLU. Now listen here. I am using total number of 200 iteration. Okay, iteration. For loop is working. Forward pass. What is the meaning of forward pass? Forward pass means sigma xi wi plus b. Okay, b j you can write, or here also j you can write. Okay, so this is the meaning of forward pass. Okay, so same I have written dot wi and input and bias. Okay, so I have done it. Okay, after then I am using ReLU. So what is the meaning of this? Mathematical notation is this. I am using ReLU, done. Okay, I am using ReLU. Then after then what I am doing? My output. Suppose this overall is z. Suppose overall is z. So I am writing here z minus output is 0 whole square. So what is the value? Z square. My value is z square. I am using backward pass. Now listen here. I am using backward. This is very important. I am using backward pass. So I am using backward pass means d loss upon d output. So what is the meaning of this? D loss upon d output. So my y is equal to x square I have written. Okay, what I am doing? D y upon d x is equal to 2x I am writing. Okay, so this 2x dy by dx at that time. So in place of this, what we did? D loss upon d ReLU. What we have written? 2x. Same we have written here. So what is this? 2z minus 0. What is this? This is 2z. Okay, this is 2z. This is d loss upon d, means derivative of loss. Okay, so this is the meaning of dl upon dr in my program. Now after then I am using d output upon d linear is equal to this one. What is the meaning of this? I will show you. Very simple method I have written here. Listen here. So what is the meaning of loss? Now see here, dl upon d w0 is equal to dl upon dr and dr upon ds and ds upon dmul and dmul upon dw0. This is the chain rule. Okay, now see here what we have written here, I have written dl upon dr is equal to, I have written 2z minus target. I have written this is z minus target. Okay, now what is this? Here I have written ReLU of derivative, okay, and z. This is the meaning of this. I want to find the ReLU derivative. Okay, I want to find the ReLU derivative because this is a ReLU. Okay, ReLU with respect to sum. If you will come in our lecture, what we have done in place of this, I will show what we have done. ReLU. Okay, so if it is less than 0, otherwise this. So here it is x, here it is 0. Okay, so if you will differentiate dx upon dx, so you will get 1. Means if ReLU is greater than 0, then you will get 1. Okay, if it is less than 0 or greater than less than or equal to 0, then you will get 0. The meaning of this. So what is the meaning of this? This r differentiate with respect to sum. Okay, so means derivative of ReLU. Now third one, this value I am not writing. Why? Because all time it is giving 1. Any function if you differentiate with respect to, in mul there is a x0 and w0, xi wi. Okay, there is a xi and wi in mul. So either you differentiate with respect to x or with respect to differentiate with respect to w. Every time you are getting 1. So why I will write? I am not writing this one. So last, this is very important. I told what is the meaning of this. So actually this is input. What I told, if you want to differentiate x0 and w0 with respect to w0, so every time you will get x0, means every time you are getting input, so you have to remember only this one. So what is the meaning of this? This is the input. If you understand this line, so it is very easy to understand the overall program. You have to learn only this one. Now what is this? Now listen here. So at first dl upon dr is equal to 2z minus t. Okay, 2z minus t, same I have written here. So my this is this one 2z minus t, what we explain, this is, I will show here. Okay, so what we explain, this is what we explain, this is 2z minus t, done. Okay, what is this? This is actually d L upon dr. Okay, this is the meaning of this. Now second, what is the meaning of this? ReLU derivative with respect to sum. This is ReLU derivative with respect to sum. This is done. Now what is the meaning of this? This is derivative of mul with respect to weight. Okay, this is the meaning of this. So this is all time input. So these 3 lines are very important if you understand these 3 lines. Okay, so already we explained here. I am explaining this one, I am explaining this one. This is all time I am not writing. This is input. So this is the input, and this is a ReLU derivative with respect to sum, and this is a loss with respect to ReLU. These 3 I am writing. These 3 I have written here. So this is the first one. Derivative. This is the first one. Okay, this is the first one. and this is the second one, and this is the third one. Okay, understand? Okay, now next. Now you can see the bias. One thing is very important. The bias is all time 1. Okay, leave it. You can also update the bias. Now here you can see what we have written here. So I am writing d loss upon d linear. D loss upon d linear. I have written d loss upon d output. What is the d loss upon d output? D loss upon d output. D loss upon d output means this is dl upon dr. This is dl upon dr. After then I multiply d output upon d linear. D output upon d linear. What is this? This is derivative, ReLU derivative upon with respect to s. Done. The meaning of this. Okay. Now next, d loss upon d weight. D loss upon d weight is equal to d loss upon d linear, means this value. Okay, this value. Now after then into this value into this value is this one. Okay, so because of this one you can check also. Now into d linear upon d weight. So what is d linear upon d weight? That is the meaning of this input. Okay, what is this? This is dm upon dw0. This is d mul upon dw0. And so overall I got, that is a chain rule. Okay, that is the chain rule. Now last, what is this? Here I am writing, this is for bias. So bias I am writing d loss upon d linear. D loss upon d linear is equal to this value. So what is this? dl upon dr into ReLU derivative upon ds into, I am writing d linear upon d bias. So d linear upon d bias is equal to 1. So I am writing here 1. Why I am writing here 1? You can see before every time it was input. Now here every time it is bias. Now why this is input? Both are same. Both are same. Before it's depend on input. Okay. And here it's depend on bias. So I am writing bias is equal to 1.0. So I updated the bias as well as I updated the weight also. Okay. So this is for W0, W1 and Wn also. Now after then I update weight. So what we are doing, weight is equal to weight minus. So weight is equal to W0 is equal to W0 minus N into DL upon dW0. So this is the meaning of this one. Okay, this is for every weight. How many weights are here? So everyone. Okay, and I am not asking for W0, W1, W2, W3. Same thing also updated bias. I am writing what? B minus bias is equal to bias minus learning rate N into DL upon DB. Okay, so this is the updated bias. So once I updated the bias, and after then I am using the iterations, and I got my final bias and weight. This is a final outcome of, so step by step with coding we explain. Okay, so if you are learning like that, then it is very in future also you can create your own model. Okay, for the research or project. So you have to learn all the steps one by one. What is the benefit of this? You can see also the benefit. Here I am writing only one program, and later I will show if there are bunch of layers, bunch of input, bunch of weights, and how to write such type of programs. If you understand our previous program and this program, next program is very easy to understand. Thank you so much.